Today we will be talking about Ipfs. It's a protocol to update the web. The presentation is gonna be structured in three parts. We're gonna talk a bit about the problems that HTTP has today. We're gonna look at IPFS, so a technical overview, and after that we're gonna look at the demo. Yeah, play around with it. There are a few problems with HTTP today. IPFS addresses those problems, but have in mind that it came in the much broader context. As of 2026, as we're planning to go to Mars, HTTP wouldn't scale for a data transfer between planets, and all the problems that we're going to talk about will scale for an interplanetary file transfer. By the way, that's what IPFS stands for, Interplanetary File System. Okay, great. Now, the web, at first, it was meant to be distributed. It was meant everybody would run a client and would run a server. In the end, it turned out to be centralized. We have a main server and a lot of clients, querying that server. Obviously, it had advantages. You had a single point to update, and everything would be okay. And there are obviously companies that try to decentralize that architecture. Obviously, to serve requests faster, to don't have a single point of failure. But the problems are still there, even if it's decentralized. We're looking to get the web back to a distributed architecture as it was meant to be. Okay, we've got the internet. This is the internet, a massive web that's interconnecting a lot of specific use case devices. That's the IP protocol, and you've done a great job so far. And then we have the web on top of that. The web. I want to make the difference between internet and the web. The web gives us this capability that anybody can upload a HTML, a CSS file, a JavaScript, and they have a website. They have a website, they put it out to the world, and potentially gives the world newer capabilities. Okay, I'm gonna come back to this idea in a minute. Let's talk about the problems. We're gonna go in detail on a few of these problems. Location addressing. How the web works today. You wanna access a website. You obviously give the domain name. A DNS query happens, and you get the location of the data you're looking for. Okay, that's you, and that's the server you're looking to access, and all the nodes in the middle are the backbone. Okay. We have the concept of online versus offline. Let's say we're in a room like this. Everybody has a laptop. A guy uploads a file or opens a Google Docs file that everybody needs to work on. The problem is that if the internet connection cuts off, nobody's gonna be able to do the work anymore. Even if the guy uploaded it was sitting next to you. Again, with natural disasters, whole regions can end up be cut off the internet, and we have human disasters. We all know about the Arab Spring. when in Egypt one day they decided to just cut down the internet for the whole country, and obviously censorship. Okay, we also have the problem of bandwidth and latency. Same example, same room, a bunch of somebody uploads a picture on Facebook. Everybody wants to see it. Let's say that picture has 1 MB. We're just gonna assume there are 8 network nodes on the way from the server to the actual client. That's 8 MB of bandwidth, which is not a lot. If you consider a video, and if you consider 30 people wanting to watch a video, let's say it's Gangnam Style, a 200 MB video. On the same example, on the 8 node network, that would be 48 GB, which kind of starts to sound a lot. If you consider the total number of views on that video, there's nearly 500 petabytes of bandwidth for one video. Okay, now we're gonna talk about Internet of Things. I'm gonna try to go fast on this. It's a big subject. We had this capability on the web that everybody can upload something and it's out there for the world. Well, with Internet of Things, we don't have it anymore. We started to have this platform, closed down platforms that if you want to, there's only a bunch of people controlling them. They decide what goes there, what doesn't go there. Okay. We're trying to bring the IPFS is trying to bring back the freedom of look, HTTP has done a great job transferring files. You can't have a browser on a watch. You're limited. HTTP is limited to browsers. So that's devices that have browsers. That's it. If it has a browser, you could add content. If no, you don't. IPFS is trying to bring that back. You have a device, maybe an earring connected to the internet, maybe a bracelet. The same thing. Everybody can put content on that, not only the manufacturer. Okay, that's pretty much the idea with the Internet of Things. I'm gonna come back to it. Data control. It's your content. You post the content on Twitter. Twitter decides if that's gonna be, rendered on a web page. If Twitter goes down, you lose that content. You don't really own that content. How would it be if you own it, you can post a link in an article, for example, that you wrote, and you have the certainty that that link will stay there for a long time. You don't have that capability now. The average lifespan of a link, it's 100 days. So that means there's sort of 404 going around. Okay, IPFS. This would be the second part. I'm gonna go back a bit in detail about the technical parts of IPFS. We want a world where you can access data even if you're offline. You're not dependent on that server. Even Internet of Things. You have a lot of devices, they communicate with a server. If the server goes down forever, you pretty much throw away the device. We want a smarter one. We want a distributed one. We don't want a single point of failure. A permanent one. Internet Archive tried to do a lot of, to archive the net, but there's only so much they can do. We want a safer one, we want a faster one. interplanetary file system, also called the distributed web, the permanent web, the Merkle web. Merkle web is very important. I'm going to get to that in a minute. So there's actually a bunch of technologies that work today on the internet, and they've got bundled together. This is how the stack looks like, the IPFS stack. I'm going to say a few words about each of them. All right, you've got routing. That's distributed hash table. It's kind of like a key value dictionary, just that it's implemented with graphs. It's a logarithmic complexity to look for a certain node. Have in mind to query about 10 million, a network of 10 million nodes, you need about 20 hoops, 20 hops. So yeah, that's pretty good. We've got the BitTorrent. That's the peer-to-peer communication. That's the data transfer. Obviously, with protocol, with a bunch of really smart processes involving, I don't know, nodes that serve content get rewarded, nodes that don't serve content get penalized. The rarest content gets served first. So that was already there. They just used it. Okay, we've got Git, and there's Merkle DAGs. I'm just gonna show you what a Merkle DAG is. This is the most important concept. If we would be to, yeah, I need to make sure. Okay. I'm just going to create a file, echo, random string, foo. Okay, I've got my foo here. I'm going to go IPFS. I'm going to show you in a minute what all this is. I just want to show the idea of the Merkle DAG now. I'm going to add foo. Okay. Okay, I'm just going to do something. Okay. Yeah, so for that, I don't know what happened. Okay, so we've got this file foo. Okay, I'm just gonna cut it, see the content. We pushed it on IPFS. We've got this hash. Basically, this hash is the concept of a Merkle DAG. The content has been hashed with a SHA-256 algorithm. So it's kind of how Git works. You've got a massive network of nodes. Each node contains data and links to other nodes. That's it. You identify a node by the hash of its content, even if that's the data, even if that's the links inside. Okay, we've got the SFS. That's what a certification authority does for HTTP. SFS does for data transfer. In a few words, a server is self-certifying itself. You don't need somebody else to say, okay, that's who he really claims it to be. And obviously, we got the web with all the freedom that it gives us. Okay, that's the protocols involved. IPLD, that's actually the Merkle DAG. You see this slim waist. The Merkle DAG is the only structure in IPFS that you're binded to. It works only on a Merkle DAG structure. All the rest, I mean, on the network, you can use TCP, you can use Tor. Naming, you can resolve it, I don't know, just from normal DNS, or IPNS stands for Interplanetary Naming System. You can play with all these protocols to suit your application. but the Merkle DAGs would stay there. By the way, their database is implemented with Merkle DAGs by default. I know Cassandra would be a good example for that. Okay, so the internet today, the same thing, works by location. Nobody cares about the location. When you want a file, you just want the file. You don't care, well, where on the world it is. IPFS comes with the idea, if you want a content, you look for that particular content, and it gets served from a peer who is the closest. You don't need to go on the backbone all the way around the world, maybe, to get something that probably is next. It might be next door or in your local LAN. This is the model that we have today, and this is the model that we're looking to get at. You're just getting content from your closest peer. Okay. Now, the Merkle DAG, it's immutable, okay? You identify a node by the hash of this content. You change the content, you change the hash. So that looks static. That's pretty much how, no, that looks like a static website. You can also create dynamic content. You obviously have a domain name, you resolve it, you get a hash. That's the hash of the public key of the person, in the example of the website, of the person who published the website. But that hash of the public key has a pointer to the last content. Okay, let's look at Git. Your master branch, it's actually just a pointer to your last update. It's the same thing here. You got a domain, that's what the end user will have. That will always get resolved to that hash, the hash of the public key. And after that, the pointer will always get updated. Okay, great, that's it. Let's have a look at what we can do with it. All right, I've got 15 minutes. It would have been great if I would have had more. Great, so I'm gonna start from the beginning. Okay, I'm gonna, IPFS can be downloaded. I'm on Linux. You just unzip it, you move the file in user local, and that's it. You've got it on your command. Sorry, I'm going to do this. Okay. So I'm gonna go IPFS init. I'm gonna initiate a local node. This is my, it gives me my peer identity, which is a hash. We're gonna talk in a minute about this. And it says to get started, enter this command. Now let's have a look. If we get the hash that is given, you can see it's just a cat command. It's mapped with Linux, IPFS / you get a hash and / readme. If I go IPFS ls, this, it's actually a directory. It's just a directory on IPFS. You can see a bunch of files in it. I don't know, we can look at readme, just get the hash. IPFS cat, and it's a readme file. You can look at it. Great. Now let's talk about a bit about the hashing. I'm gonna do IPFS object get. That's a bit more than cat and ls. Object more also retrieve the raw data, also with metadata in it. Okay, let's try the readme file. Okay, so that's the raw data. It's actually in JSON format. We can do encode and JSON. We get the JSON. I'm gonna do protobuf. IPFS understands JSON, protobuf, and XML. It's gonna encode it in protobuf, And if I'm gonna do multi-hash, I'm gonna get this hash. I have a look up here. I'm gonna ls again the initial directory we played with. Ipfs. You can see our hash, it's identical with the README hash. So that's how it works. We just hashes content. You look for content, not for anything else, not for the location of that content. Okay, let's play a brain. I'm gonna do a directory. I'm gonna, I don't know, just put a file in it. Okay. I can go ipfs add and add the whole directory. And I get a hash for each one. I can, if I ls the directory hash, okay, I get the two files. I can cat them. I don't know, let's say cat this one. Okay, I get the disk string that's inside. Let's start a server and see what we can do with it. Ipfs daemon. We're gonna start the Ipfs server. We're gonna have a port open on 401. It's a port open to connect peer-to-peer. 501 would be a web UI, and 8080 would be our local gateway. Okay, let's have a look. So 501, it's our local server. Okay, localhost 501 web UI. Okay, the web UI resolved in a hash that we were talking about. I'm just gonna copy it. It's resolving. Okay, I'm just gonna leave it in the background. I'm just gonna ls this website, see how it looks like on the inside. Okay, it's not, the internet connection doesn't help me. Yeah. Okay, let's try something else. I'm gonna do this. And say DefCamp, def, ipfs, def, and I get this hash. There's also, so you've got your local ports open. There's also a global gateway. If I go ipfs.io/ipfs and I paste the file that I just pushed online. Okay, doesn't happen. Does it? Okay, I'm gonna do this. Yeah, I need the VPN around here, didn't I? Let's see if it works without the VPN. gets result here. So I should get result here. But it doesn't. Okay, one last try on something else. Yeah, I'm sorry. Huh? It doesn't help me. Okay, we have the internet. Great. So slowly taking them. Yeah, no, there's no point of going forward. It just doesn't help me. I don't have the VPN anymore. Yeah. Usually IPFS Swarm peers should give me the peers that I'm connected to. This is their ID. If I go IPFS ID, it's gonna show me my own ID. Uh, this is my ID. It's just the hash of a public key. It's RSA generated. Also got IPFS bootstrap. These are the main peers that you connect to by default when you need the daemon. I also wanted to show a bunch of pictures. Let's see. IPFS add 3 JPEG. Great, it worked. Okay, we get a hash. So, okay. This is how tree.jpg looks like. It's a picture of the tree. It's a pretty, it's more than a, it's a pretty big picture. So I added on IPFS, I've got a hash. If I ls the hash, have in mind that it's just mapped with Unix commands. You can do cat, you can do hash, you can do a bunch of Unix commands. IPFS, ls, and I have, I ls the picture. You can see that the content was split into 4 hashes. I can do IPFS, cat. Okay, I'll do this and I'm done. Some questions. Um, if I cat it, let's say test JPEG. Okay, let's take the next one, do the same thing. Okay. And if I open it, what's gonna happen? It's gonna be only half of it. Basically, that's how it works. It splits the content in more hashes, and you can get each content from different each hash from different pairs. Okay, yeah. I would have liked to share stuff on the internet, but I'm just not. Here we go. It got resolved. This is the global gateway, ipfs.io/ipfs, and here I give the hash of the file that I've just pushed on ipfs, and it got rendered. Yeah. This is your 501/y. Great. Now, this is the IPFS server that you've got locally, or port 5001. You have a web UI. You can play with it. You can see your connections, your peers, connected with 0 peers, but that's not really true, is it? IPFS, Swarm peers. These are the peers that I'm connected with. So for some reason it doesn't help me. Yeah, okay, questions. I would love questions. So I can detail on at least on the important part.
Hi.
Hello.
I've actually used IPFS. I have
Okay.
I have two problems.
Okay.
One, there's no privacy unless you manually encrypt the files you want to share.
Okay.
And so I guess the question is, how would I go about sharing a file with only a group of nodes? That's one. And two, um, sorry, I forgot what I was going to say. No. Um, there's no replication built in. If you want to replicate a file onto multiple nodes, those nodes would have to manually download the file knowing its hash.
Okay. And replicate it.
I mean, the file right now resides on only one node. And
Right.
if that node goes down, the file is no longer accessible, right?
No, you probably have it cached somewhere else. Yeah, that's the idea. As soon as you access a file, it gets cached, and
If I access it myself or
yes,
someone else?
someone else, obviously. I wouldn't be sure to tell you if you just push it online, and if you go offline after, it would be there. But if someone else accesses it, that's it. That's online.
Okay,
You
so
just need a couple of caches.
that's the point. You have
Okay.
to actively access it so that it
Okay.
becomes replicated.
There might be a central caching involved. I'm not really gonna go into this because I'm not sure.
Okay.
Um, but yeah, it might be. And regarding your first question, um, yeah, it's true. The data is not encrypted. Um, the good part about it, with HTTP, you need a hashmark algorithm. You have a data, you have a message, you encrypt it, and you send the message along with the encryption. The person receiving it needs to um, no, needs to encrypt the data, no, hash the data, and see if the two hashes match. If they match, that means the data wasn't altered, wasn't tampered with. IPFS does that by default. As soon as you change the data, the hash changes. So if you retrieve a hash, you're certain.
Okay, so guaranteed
I know.
authenticity,
Okay.
but I was talking about
True, true,
privacy.
true. I know. It gives you data integrity, but yeah, I wouldn't really go into that subject. There might be workarounds for it, but yeah, it's not by default. Okay.
Thank you.
Thank you.
Hi, my name is
Hello.
Dan. I've never used the IPFS before, so this might be a stupid question, but
Hello,
I'm not really
Dan.
sure. I didn't actually understand. Is there a central node that does indexing?
Okay.
So how do I know where can I get a file from? I'll just ask all of my peers, does anybody
Yes.
have this file? And if
Yes.
they don't,
You do two stages. You ask, okay, I want this file, and who has it, and you get a bunch of nodes that say I have it, and after that you ask who's the closest one, and you
what
will
if no
retrieve
one
it.
has it? So I've got like 10 peers, my peers don't have it. What's next?
They're connected to other peers.
So they ask,
Yes, they go. Is that DHT querying? Yeah, they will
so it's
find
kind
it.
of like a recursive DNS.
Yeah, exactly.
All right.
Exactly.
So isn't this system like prone to multiple DOS attacks?
Okay, that's a good question.
Can't I just make up hashes and start querying them?
Okay. Yeah,
That's it.
true. That's a good question. I wouldn't really want to go into that. I play with it as I'm a hobbyist. I play with it for fun. I'm not a developer on it. So I would like to answer that question, but I'm not. Cannot.
If I may ask a question, maybe I
Yeah, please.
missed from your presentation. I'm not sure if you explain it, but all I have seen from your demo
Okay.
is that you have been searching for files
Okay.
by hashtags.
Yes.
Okay, so I'm not using IPFS and I'm not used to use hashtags.
Okay.
If in this network I want to search for some resources, some files,
Yes.
how would you do it?
Yeah. You look for
Well,
the.
I don't want to search by hash, first of all.
You will have a domain name.
The regular user, I want to search for
Look,
a file.
you will have a domain name that will get resolved to a hash. The end user will never gonna notice it. If this technology had to change the way the end user thought about the internet, that would never get implemented. For the end user, it wouldn't be any difference.
So will be some domain name servers
Okay.
that will translate the hashes in normal,
Exactly.
human readable names.
Yes. A DNS server. We can use it with DNS or with IPFS own naming service. That's gonna get resolved to a hash, and that's gonna have a pointer to the last content. Always have a pointer to the last content.
Mhm.
Yes. That's a case of dynamic content.
Okay, thank you.
Okay.
All right, so
Yeah, please.
this brings me to another question.
Right.
What if you have two files with different content but same name?
It wouldn't happen. You hash the content. If I add another letter to a file, the hash changes. So you have.
Right, but I'm searching for the file.
Okay.
How does that translate to a hash?
The name of the file doesn't matter. I
Okay.
can have file A and file B. If they have the same content, the hash is identical.
Right. Yeah.
Yeah.
No, I think I got it. I know where where I had my issues. Yeah. Thank you.
Okay.
Yeah, hi.
Hello.
I didn't quite catch the implications of the first question. And by this, I mean, if I push a picture of myself to the IPFS storage, yeah,
Okay.
and it gets cached by a server somewhere.
Okay.
So the owner of the server can view the picture, right?
Yes.
Oh, nice. Okay. That's it. Thank you.
Yeah. Okay. Well, as we see in the example of the picture, the picture gets split. In this case, it gets split into four parts. You get each part from a different peer. Yeah, when you have dynamic content, when you push a new version of a website, or somebody uploads something on the website, um, the hash of the website changes. The hash of the website will change, and yeah, there's that pointer that gets updated with always the last version of it. Yes, yes, it's implemented from Git. That master file that always points to the last content. Yeah.
I was
Okay.
sorry. I was wondering if you've heard of Ethereum Swarm.
Say again about.
Ethereum Swarm. It's a project similar to IPFS,
Okay,
but
no, I
it
don't.
wants to leverage the Ethereum network to share files like IPFS does.
Okay, and what would be different?
The Ethereum is a very large network right
It's
now.
not on top of TCP.
No, you know Ethereum,
Yeah.
okay,
maybe.
so there are a lot of miners online,
Okay.
and on top of doing mining for Ethereum, they could
Okay.
also share files.
Okay. Okay.
That
We-
was-
okay. IPFS is at a stage. Linux distribution use it for this package manager. You don't need to have on the to go on the backbone to get a package. Maybe it's next door. It's gonna be integrated in the browser. There's also an add-on that helps you resolve hashes straight in the browser, so you don't need to go like IPFS / or go on the global gateway. You're just gonna pipe it straight away. So yeah, there are a bunch of implementations to integrate with the current technology.
Then I guess one last question.
Yes.
You said this would help with the transmissions to Mars. How do you see that happening?
The problem is that you need to cache it locally. A lot of times when you do a query, maybe you have it, maybe it's in your computer. You accessed Google yesterday. You don't need to go on the backbone and get it. Maybe, yeah, that's the caching, which data transfer wouldn't scale with location as it is today with HTTP. Wouldn't scale for such a big project.
I think I understand. Thank you.
Okay, great, thanks. Thanks for the questions.